Okay, unfortunately the camera wasn't on when I did this, but it's fairly simple, and also the MCR videos that are going to be posted along with the videos from today's class do the same thing. So, but just a brief comment on fractions and then how they apply to rational functions. Because we want to get this out of the way so we don't get confused by this when we're trying to do that. Okay? So, 1/2 plus 2/3 is not 1 plus 2 over 2 plus 3. You don't add numerators and add denominators. You don't do that. If you did, then 1/2 plus 1/2 would be 1 plus 1 over 2 plus 2, which is 2 over 4, which is 1/2. Well, 1/2 plus 1/2 is not equal to 1/2. If you got half an apple and another half an apple, you got more than half an apple, right? So that disproves this fallacy that I keep seeing. I've stopped being incredulous about it because people haven't had to do fractions since they were 10 years old usually. Bad design of the curriculum. Okay. So let's do 1/2 plus 2/3 correctly. Okay, well, you should remember, and this should ring a bell, but we're going to work it out more rigorously. 1/2 plus 2/3, well, 1/2 is 3/6, and 2/3 is 4/6. Now, if you got 3/6 and you got 4/6, then you got 7/6. You got 3 of them, you got 4 of them, you got 7 of them. From them is sixths. Okay? So that's pretty straightforward. Details. How do you do this formally to make sure that it makes sense and that it works? Because you're going to have to do it when you get these because you won't have numbers to work with. Okay, well, you say 1/2 plus 2/3 is, well, we know that we want to get the same denominator for both of them. And we can do that if we multiply this denominator by 3 and this denominator by 2. You're going to get 6 either way. So we can't just multiply the denominator by 2. That would change the value of the fraction. If I multiply 1 over 1/2 and multiply the denominator by 2, it gives me 1/6, and that isn't equivalent to 1/2. Well, formally what we do is we say 1/2 then multiplied by 3 over 3. Because if I multiply by 3 over 3, I do multiply the numerators and multiply the denominators. And 2 times 3 is going to give me the 6 in the denominator, and it's going to give me the 3 in the numerator. Now, why can I do that? It's because 3 over 3 is just 1. And if I multiply 1/2 by 1, I get an equivalent fraction. I get something that has exactly the same value that 1/2 does. So 1/2 equals 3/6 formally because we multiply by 1 in the form 3 over 3 to get 3/6. And then we multiply by 2 over 2 to get 2/3 into the form of 4/6. Again, we're just multiplying by 1, so we haven't changed its value. We just changed the way it looks. And now we have 3/6 plus 4/6, which is 7/6. Okay? Now down here, I want to add this to this. Okay? It's not much harder than this, it's just messier. It takes longer. The idea is exactly the same. We've got a denominator here and we've got a denominator here, and they're not the same, so we can't just add the numerators. But we can make the denominators the same very easily. We just multiply this denominator by x plus 5 and this denominator by x plus 4 times x plus 7. We would have the same denominator, but we can't just multiply the denominators. What we do is we take this thing, we know we want to get x plus 4 times x plus 7 times x plus 5 in the denominator, so we multiply this fraction, which is here, by x plus 5 over x plus 5. In that case, we're just multiplying by 1. Okay? And then what do we do for this one? Well, we want the denominator to be this, so we better multiply the denominator by x plus 4 times x plus 7, which we do here, but we change the value if we don't multiply by x plus 4 times x plus 7 over x plus 4 times x plus 7. So we do this. Now, it's important to know that that's what you do, but it's important to know so you're sure that you're doing what you need to be doing, that you know that you're multiplying by something that's equivalent to 1. so that you're not changing the value, you're just changing the way the expression looks. Well, if we do that, then clearly this numerator becomes this times this, there it is, okay? And this numerator, I'm not going to read it to you, becomes this times this, which is here. And the denominator in both is going to be x plus 4 times x plus 7 times x plus 5, so we can add the numerators in that case. And here we have it. Now, I'm going to ask you for homework to expand something like this. I might ask you to even expand this specific expression, okay? But that's easy to do using the distributive law. We've done the distributive law. You should know how to do that. If we find that people are having trouble with it, we'll probably, we've done it in MCR, we might do a little more in the MCR, some videos. We might mention it again in class just to clarify it, depending what kind of errors I see. Okay? So, that's all I did. That's adding fractions with symbols, and there's really nothing to it except a big messy set of tedious calculations. Okay? Not a big deal. Get used to it. Understand why we do this, and then see that we're doing the same thing here, just with symbols rather than numbers.